Hello friends, so our today's question is longest common prefix. So what is given in this question is we have to write a function to find the longest common prefix string among an array of strings. Okay, so we are given an array of a string and we have to find the longest common prefix string among these array of string. Okay, so what is prefix string? Prefix string is something that appears in the starting of any string. Okay, so prefix is something that appears in the beginning and suffix is something that appears at the end. So we have to find the prefix string, common prefix string among the array of strings. Okay. And if there is no common prefix, like in this case, where we don't have any common prefix string, so in this case we have written an empty string. Okay. So what basically questions is that like this is the array of string. So we need to find the longest common prefix substring among these that is common in all of the string of this array and we have to return this. So for in this case if we check f is common for all the strings present in this array and then we talk about the second character. So fl is also common among all the three string of this array, but o, if we take the third character now, so o is common first two, but in the third string we have I in place of o. So what will be the answer for this? So FL will be the answer for this string, or we can say it is the longest common prefix among these array of string. Okay, so this is our required answer. So what we have to, like, we have understood the question. Now approach that we can use here is like, okay, so first of all the first approach that we can use here is, okay, so we can find out the shortest string among these array of strings. So in this case flow is the shortest string. Okay, now we can check this string among all the string present in this array, whether it is substring of all these or whether it is equals to all these, whether it is present in this strings. Okay, so flow is present in this, flow is present in this, but flow is not present in this. So what we will do, we will reduce last character from this string. Okay, so now what we are left with? Flow. So it is present in first string, it is present in second string, but it is not present in the third one. Okay, again, so it will not be our answer. So it we can again remove the last character from the word. Now we are left with fl. So fl is present in this, fl is present in this, and fl is also present in this. So yes, so it is present in all the string which is provided to us in an array. So this is the required answer. So this will be our common prefix substring for this input array. Okay, so this is our string. So basically this is our approach, but for this case now, if we consider time complexity, so let's suppose the length of this string is n and the length of the array which is given to us is m, so it will take n into m time complexity. Okay. Okay, so it will take capital O of n into m time complexity. Okay, so we will be looking for the better approach, or we can reduce the time complexity to capital O of n or n log n. So the second approach, we will look for the second approach. Okay, now we know that if if f is the solution for this particular input array, if f is the solution, so it should be present in every string of this array. If fn is the solution, then it should also be present in every string of this array from the beginning. Okay, so we know this thing. The one thing is clear. If fl is present in first string, it will also be present in the last string. It will also be present in the string between first and last. Okay, so what we can do here is like we can short these array. Okay, so first of all we can short these arrays. So after shorting, what will be our result? So we have sorted these array. Okay, now we can see like, so when we sort this, so these will be sorted in alphabetical order, like L, then I. So I is coming first in our alphabet. So I is sorted first, then O, then O. Okay, so in this way, when we sort this array, na, so they are arranged in alphabetically order, or we can say lexicographically order. Okay, now what we can do is we can check the first one and the last one, because if f is the solution, it should present in all the in first and the last, and all the string which are occurring between first and last. Okay, so if as we have sorted this now, so if it is present in first one and it is also present in last one, then obviously f will also be present between the strings which are present in between. Okay, if fl is present in first one and fl is present in last one, then it is obvious that fl will also be there in the string between first and the last. So this is basically our approach. Like if certain character is in the first string from the beginning and certain characters is in the last string from the beginning, then that character will also be there in the string between the first and the last in the beginning. Okay, so this is basically our approach. So in this way we can find the common character for the first and last and we can return that answer. So I think the approach is clear for us. Okay, so now let's look at its implementation. So first of all, what we will do, we will sort our array. So we have sorted our array. Then what we will do, we will have two variables. First, that will have first string in that, and last to have of last. Okay, so strs dot size -1. Okay, so we have our first and the last. Now what we will do, we will have okay, we will have another variable string result that we will initialize with empty string. Okay, so what, why we have initialized it with empty string? So as we find any common character, okay, so we will add that into the result. Okay, so now let's check for int I is equals to 0, I is less than. Now we can travel to like okay, so in this case, like we have fight and flower. Okay, so we have to like iterate up to the minimum length of these two. Like these are having the same length, but if we have fight and flow, then in this case we have to just travel to the minimum of these two length. Okay, so we will find. So we will have here I2 minimum of what? First dot length and last dot length, then I plus plus. Okay, so now what we will do, we will check if certain character first of I is not equals to last of I. In this case we will break the loop. Okay, and in other case we will add that if they are equal, then we will add to our result. And then after the loop is over or we break the loop, we will return the result. Okay, now we can run this. So it is accepted. Now we can submit. So yes, it is submitted successfully. Regarding its time complexity, so as we have short these array, so it take capital O of n log n time. Okay, so n log n time is taken for sorting. Then for any of the we are iterating, we are having the second, we are having this loop. So we are iterating to any of the, let's say the length of the first is capital O is n. So its time complexity for iteration will be capital O of n. So its total time complexity for this particular solution will be capital O of n log n. Okay. So this is our time complexity. So in first approach we have seen our time complexity was capital O of n into m, and for this second approach we have our time complexity reduced to n log n. So this is basically a solution. So thank you for watching.